This is Unit 3, Triangles. Preview video 3.3, Triangle Guts. Take a moment. Please don't skip this part. Once you close your eyes, just take a slow inhale through the nose. Hold your breath. Exhale 5. All right, for this particular lesson, it is very important. You need two very essential tools. You need something called a compass, which is one of these. It was part of your equipment required in this class. And you need a straight edge of some sort. Compass and a straight edge. We're going to be talking about triangle guts today. Triangle guts, which means the inside segments inside a single triangle. There's 4 of them. 4 main triangle guts, if you will, the insides. Yes, you must memorize these. These 4 triangle guts are median, altitude, perpendicular bisector, and angle bisector. Median, altitude, perpendicular bisector, angle bisector. We're going to draw a baby version of each of these and then get a little bit more detail here. So a median connects vertex to midpoint, vertex to midpoint. So if you eyeball, if we want to do a median from L to the midpoint here, hatch mark to prove it's a midpoint, we'll call that midpoint Q. The segment that connects the vertex to the midpoint, that is called a median. Vertex to midpoint. That's called a median, that segment. An altitude goes vertex to right angle in the opposite side. Right angle does not necessarily go through a midpoint. In fact, it doesn't most of the time. That's an altitude. Straight down. A perpendicular bisector does exactly those 2 things. 1, it's a bisector, which means it's a segment that goes through a midpoint. 2, it's perpendicular, which means creates a right angle. So a perpendicular bisector is a segment that bisects a segment and makes a right angle. Notice it doesn't necessarily go through the vertex. An angle bisector. If you sweep this angle here and imagine the middle of that angle. Now, an angle bisector is all about the angle, not the side. So when I draw an angle bisector, I always take it through the opposite side to de-emphasize it. It is the bisector of the angle. So this point here is not a midpoint under most circumstances. Under a couple it is. But your eyeball for an angle bisector is on the angle. Those are your 4 triangle guts. Say a quick word about an altitude. We're going to just draw 3 quick altitudes here. So draw it with me. That's vertex, right angle, all 3 sides. There's 1. See what I'm doing? Each corner. Well, that's not a good right angle. Let's make that actually look like a right angle. Close. Right angle. Vertex, right angle. So here you can see all three altitudes. By the way, the point where it crosses, that's called an orthocenter. All the altitudes in an acute triangle are inside the triangle, inside. In a right triangle, you have one altitude that is inside. And because it goes vertex to a right angle, your other vertex right angle are actually the sides of the triangle itself. Vertex right angle. So in a right triangle, one altitude is inside and two is on the triangle. Things get really strange in an obtuse triangle. In an obtuse triangle, one altitude is inside. And to get straight down from this corner, you actually have to extend the side and then straight down. So one altitude is outside. Vertex right angle. So in an obtuse triangle, one altitude is in, but two are completely outside the triangle. That's a very common try to make you think weird in SATs, is they'll use obtuse triangles and ask you how many altitudes are there. A lot of students only say one. Now for the next couple minutes, we're going to focus strictly on a median. Strictly on a median. So take a look here at this triangle right here. And it says, in the diagram below, mark the midpoint of LM, point R. So we're going to do right here, LM. We're going to get that as accurate as we can, point R. And the midpoint of MN, point S. So MN, midpoint as close as possible. We're going to call that S. Finally, the midpoint of NL, what looks like the middle, point T. Now, we're going to connect all of these midpoints to the opposite vertex. Opposite vertex, that's a median, folks. Opposite vertex. Opposite vertex. If you've done this accurately, you will actually cross all three at the exact same point. That's called a centroid. And there's a very important property here, and the reason why we're doing it in real time is I want you to get your pincher fingers out. Ready? I'd like you to finger pinch from the centroid to S. Now come over here and compare it this way from L to the centroid. Just compare that distance. You noticing something? Let's do this one. Ready? Finger pinch centroid to R. And bring it up to this other portion and compare that with your fingers. Last one, from T to the centroid. And compare it right here. That's probably the easiest to see. What you should be seeing is the distance from the centroid to the midpoint, that you simply double it the other portion of the median. So there's a 2-to-1 ratio going all the way around here. Let me color code it. 1 bunny hop, 2 bunny hops is what you should have noticed. 1 bunny hop, 2 bunny hops. So this is a 1:2 ratio. That's true of all centroids. So that gets us a very important concept here. A median is a segment that connects vertex to opposite midpoint. We're just going to quick sketch a couple of them here. So eyeball the midpoint here, hatch marks. Let's make a median. Prefer you to use a straight edge. Here's one. Let's do this median right here. You'll only need 2 medians to find the centroid because you only need a point of intersection. All right, so these are both medians, and they cross at a centroid. And the most important thing here is that this distance, midpoint to centroid, is half of the distance from centroid back to the vertex. So let's fill out thing equations. So this distance AG is twice as big as CD. This is called thing equations. You see what I did there? I said that our segment AG is 2 of CDs. That's a thing equation. Let's do another one. C to G. C to G is 2 of GF. E to G is 2 of G to B. Those are called thing equations. You should be familiar with those. We're describing the segments. So let's do some problems that use a centroid. N is being identified as a centroid. All 3 segments are medians, which means that's a midpoint. Just put your hatch marks on there just so you reinforce that these are all midpoints. And we are told that H all the way to K is 24. We want to find H to N. So this whole thing is 24. But the relationship we have going on here, this is 1 bunny hop, 2 bunny hops. So we have an X, 2X relationship here. So our thing equation is HN plus NK equals HK. That's our thing equation. 24 goes there. HN is going to be 2X, NK is X equals 24. X equals 8, which means H to N is 2 times 8, so it's 16. We are told that XL and WK are medians, which means, once again, we have midpoints. And this is a centroid. I'm going to color code this for you. WK, the whole thing, is X plus 3. f to k, which I'm going to do green, is going to be negative 7 plus x. We want to find x. The problem is we're missing a complete segment here, which I'm going to do f to w. Now you cannot just call that x because we already have the variable. So let's do our thing equation first. Our first thing equation is simply this. The red wf plus the green f to k equals the blue, which is wk. That's our thing equation. If you do this in colors, it really makes it pop. Red plus green equals the blue. You good? Let's do our thing equation. F to k we already have is negative 7 plus x. Wk is x plus 3. This is 2 times k to f. So wf is simply twice as much as negative 7 plus x. There you go. Now we can solve. Collect like terms. And we get x equals 12. Now, let's see if it actually works. If x equals 12, that means wk, which is our blue, is going to be 12 plus 3, and that is 15. Negative 7 plus 12 would make this 5, and then 2 times 5 would make this 10, and there's your check. So the basic rule of thumb here is that this segment, midpoint to centroid, is 2 bunny hops for the rest of the segment. Working with angle bisectors and triangle guts is very easy. We'll do one simple problem together. We are given the fact that AP is an angle bisector. So this P is not a midpoint, instead it's a bisector, so that's true. So what's true here is the fact that angle 1 is equal to angle 2. What's also true is the fact that angle 1 plus angle 2 equals the bigger angle CAB. So let's see what kind of information we're given here. We're given the fact that angle 2 is 2x plus 13. And we're given the fact that this bigger angle is 8x minus 6. We are missing angle 1, but it's pretty easy to see what angle 1 is because angle 1 and 2 are the same thing. So we can simply double it and write 2x plus 13. And you solve. x equals 9. Didn't ask for x, it asked for an angle measure. So you come up here and we want to find a measure of angle 2, so that's 2 times 9 plus 13, which is 18 plus 13, which means this angle right here should be 31, which would make this 31, which should make this 62, which if you do 8 times 9 and then you subtract, you get it. Take that back, that's not 9, that is 8. That's why we do a check. I did that far too quickly. 32 divided by 4 is 8. Should have said it out loud. And we come up here. 2 times 8 is 16 plus 13. Let's do this in the margin. Should have done my hand longhand. It's 29. That's why we do a check. If this is 29, that means this should be 58. Let's check that. 8 times 8 minus 6, 64 minus 6. Yes, and that's 58. That's why we do check, folks. Ready? This page you're going to do on your own. Pause the video and then restart. You should have a red pen handy, folks. Ready? If YF is 16, F to D is 8, therefore Y to D is 16 plus 8, you should have gotten 24. If HB is 30, this entire thing is 30, this is a 1 bunny hop and 2 bunny hop, which means 30 divided by 3, so F to B would have to be 10. Down here, if this entire angle X, Y, Z is 72, and this is an angle bisector, angle 2 is going to be 36, which is half. Right here, if angle 2 is 23, and that's an angle bisector, this entire angle is simply double of that. You should have gotten 46 degrees. Now I'm going to introduce you to the amazing world of constructions. If you need to, pause the video because you need 2 items. You must have a compass and a straight edge here. A compass and a straight edge. I'm going to introduce you to the amazing world of something called constructions. First off, let me define what is the difference between sketching and a construction. Sketch is a freehand drawing. So it's just a freehand drawing. So when I say sketch, it just means nothing but your pencil. A construction, if you see the word construct, folks, on the instructions, it means it is a drawing using specifically a drawing compass and a straight edge. Notice I'm not using the word ruler, and that's because literally for hundreds of years, people have been using some sort of equivalent of a compass, even if it was just 2 sticks with one burnt at like charcoal and tied together with string and some sort of straight piece of wood without any notations. They've been doing constructions literally for hundreds and hundreds of years. So It's a very ancient drawing technique that was enabled people to do very accurate drawings with accurate right angles, accurate bisectors, when we did not even have numerical rulers or a protractor. How were people drawing, for example, like accurate drawings, draftsman's drawings of things like the Parthenon and the pyramid and things of that nature, when they didn't even possess an actual ruler or a protractor? They used a compass and a straight edge. So let me show you the difference. We're going to go back and forth between what's called sketching and constructions. You must have a ruler right now. I know the difference. Follow along. If you want to sketch a midpoint of PQ with a midpoint M, you simply do this. PQ, you eyeball what looks like the midpoint simply by eyeballing M, and then of course you add the notation. Ta-da! You have a midpoint M on segment PQ. That's a sketch. That is not a construction. Now, when you use a compass, couple rules. One, you need to make sure your compass is relatively stiff. If you have a very loose compass, like you go to touch it and it just flops all over the place, you can see my compass actually has a little screw on it. You might want to get yourself a screwdriver and tighten that screw. Your compass should be relatively stiff. Two, when you use a compass, you never grab it by twirling with grabbing both arms. You're going to be holding from the top, and watch, it's a tilt, drag, or twirl motion. Tilt, drag, twirling motion. You do not grab from down here. I recommend you first watch. I'm going to do everything twice. You just watch. Do nothing but watch. Then follow. We're going to construct a midpoint. The same segment. Watch, just watch. Then follow. To construct a midpoint, you put your compass at one of the endpoints. Oh, it's PQ. Let's at least label PQ. PQ. You put the end point on one of the, either P or Q, it doesn't matter. You open up the compass so it looks like it goes just past the middle. See, my finger's about where the middle would be. Now, you pick up the compass, and either from this point or from the top, it doesn't matter, but it's a tilt, and give a large sweeping arc, a very light arc. Large sweeping arc. Then you go to the other side without changing that compass distance. Plant it at the other end point. Large sweeping arc. You have 2 points of intersection here. Then you take the point of intersection. You must use a straight edge. Line it up with that straight edge. Boom. Now you have the exact, precise, constructed midpoint. If you needed to, you can get your ruler out and measure, but it's the exact precise. But remember, people were finding the exact precise middle using a compass long before we had rulers. Now, pick up your compass and follow with me again. Plant the pivot on one of the endpoints. Open up your compass just past what looks like the middle. Pick up the compass slightly, and either you're twirling, it's a tilt twirl motion, tilt, twirl. Don't change the compass setting, go to the other side. Tilt, twirl. Where they intersect, you grab your ruler, Once again, you line up those points of intersection. There's your midpoint hatch mark. That's how you construct a midpoint. Let's do something else. We are going to sketch first segment PQ perpendicular to ST. Sketch, that means just draw. Here's your S. So we're just going to go through like this. Call that T. And we just put our right angle box and ta-da, we have sketched two segments PQ perpendicular to ST. That's a sketch. But if I were to stick a protractor here, I could be a couple degrees off. It could be 87, it could be 91. So how do you get a perfect 90-degree right angle when you don't have a protractor? You can use a compass. How do you construct a perpendicular line? So PQ. Here's the technique. You're going to watch and then you're going to follow. I call this smiley, dimple, dimple. Do it with me. Ready? Smiley, dimple, dimple. Let me explain. Step number one is you place your pivot on some point. If I want a perpendicular to PQ, I just put a point there. I put my drawing point, my planner point there. I open up the compass so it's just past the segment, just past. Don't open it up all the way over to the other side, just a few millimeters past. Pick up your compass and you do a smiley, a sweep. It's a tilt twirl motion. Tilt, twirl. Don't change your compass setting. You have 2 points of intersection. I call these the dimples. See? Dimple, dimple. You put your compass on one dimple. Don't change your compass setting between dimples. And do a sweep. The other dimple, do a sweep. You will see there's a point of intersection. And now you connect, we'll call that point T. You can connect S to T. If you've done this correctly, this right here is a perfect 90-degree angle. Let me do it again so there's no confusion. It's called smiley, dimple, dimple. So I plant the pivot. Now, some of you might find it easier actually to twirl the paper instead of twirling the compass. That works too. It could be a little bit more awkward. A few people find it better. So let me show you what that might look like here. You just take it and you sweep a smiley. So you get your 2 points of intersection. You put your compass on one point. Sweep. Your compass on the other point. Sweep, and where they intersect, you line that up with a straight edge, and you have made yourself a perpendicular line. Smiley, dimple, dimple. We have one more. This is my personal favorite. I have no idea why. It seems easy. So we are going to sketch QH as an angle bisector of PQR. So we have PQR, and if we were to sketch QH as a bisector, we simply eyeball it. We call that H. Sweep, hatch, and now that's a bisector. That's called a sketch. But once again, if I were to put a protractor here, I could be a few degrees off. How do I get it exactly and precisely in the middle? That's called a construction. So ready? We're going to do the same thing. We're going to construct an angle bisector of PQR. The process is similar. Smiley, dimple, dimple. Do it with your mouth. Smiley, dimple, dimple. Let me show you. You put your pivot on the vertex. It doesn't matter how far you open it. And you sweep a smiley. You go up to the one of points of intersection. I call those the dimples. Keep the same compass setting. Sweep an arc. Sweep an arc. Where that intersects with this, you draw your straight line. I'm not going to draw it yet. And I'm going to do this one left-handed just so I can respect you lefties. Some of you lefties might find that twirling the paper actually works easier. So here's the same thing with the paper twirl. I plant, and instead of twirling the compass, I hold it and I just twirl the paper. I get a smiley. Come up to one dimple. Twirl again. The other dimple. Twirl again. And that point of intersection, you go through, and we're going to call that QH. Now, if you were to get a protractor out, these angles would be exactly congruent. That's why it's more precise. Make sure you do your summary. What are the main things you have learned in this lesson? Quick little summary. What are the definitions of the guts? And you are doing it right there.